Well, welcome to today's lesson, and today we're going to be looking at the DY-HV20T and the DY-HV8F Mp3 players. So let's have a look at the specifications for these boards. So these boards are available on AliExpress. Here we have the HV20T, and if I click on this link, you've got the HV8F. Now, the big difference between the two is that the 8F is a internal storage. It has 8 megabytes of storage that you can download your files to. If you go to the HV20T, you can see that it's got a TF card slot, so you could have 32 gigs of sound files. Now today I'm going to be using the HV8F. The system for using them is identical. The reason I'm using the HV8F is this again is for a model railway for some sound effects, so I don't need huge amounts of storage. However, on this card I think I've only put 12 files for my project, and that has filled up the 8 meg of memory that is built into the HV8F. So if you're thinking of downloading your favorite music track to one of these boards, you will need the HV20T. Now, in a previous video, I've already looked at the DY-HV8F and its equivalent, the DY-HV5W. Again, the difference between them, one has the built-in storage, the other has the SD card. I used the version with the SD card for the last project, but it means that if you go to the Digital Town website, we are on the components page, and you can either scroll down to the various MP3 players. It means that the code that works with the DY-HV5W, whether it be with the ESP32 or the Arduino or Mega 2560, will work with the DY-HV20. So I'm not going to go into all the code as I would in the same detail, because what I want us to do today is to focus on using the busy pin to trigger the next track that will play, and some of the issues that you will find around using that busy pin. So let's get on and start to look at the code. Now, as always, the resources are there. Just click on the various items and you've got obviously the circuit diagram. Click on that one for a larger version. So let's just do that. Now, one of the things to note on this board, it takes a power supply between 6 and 35 volts. This is a 10 to 20 watt version of the board, whereas the other version that I was using before is a 5 watt board. So this is ideal if you need a better sort of like playback quality, better playback volume. I must admit, in testing I have been very impressed with the sound quality, but obviously that is going to require a separate power supply. I'm using 12 volts to power mine. Then from the ESP32, connect up the grounds. I'm using pin 15 for the busy pin, and then I'm using serial 2, so RX2 is connected to the board's TX, and the TX2 is connected to the board's RX. Finally, there is a speaker that comes off. Now, when I started to use this board, I must confess I was a little bit nervous. Seeing 6 to 35 volts, I needed to make sure that any voltages going across from the busy pin to the ESP32 were not going to be greater than 3.3 volts, otherwise it's going to mess up my ESP32 and will let the burning smoke out. So I fired this thing up and just put a multimeter between the busy pin and ground, because on this board the busy pin goes high when the track is not playing. So a bit sort of, it's not very intuitive, but when nothing's happening the busy pin is high, and I was getting 3.3 volts, therefore I was happy to connect it up to the ESP ESP32. One other item is before you can use the serial UART connection, you need to set these pins, and they need to be set with 1 as off, 2 as off, and unlike the photo, 3 needs to be on. Now, if I go back to the components page, you will see that I have listed the dip switch settings. And now going over to the desktop, you can see that I have set the pin correctly, that dip switch 3 is the correct setting. You'll notice this is the old 5-watt version, and I've just put it on the desk as a size comparison, but they're basically the same item. One other thing to note is there is a manual volume control. Now you can set the volume via software, but there is, if you like, you just put a crosshead screwdriver in here and turn this round. I have got it set to flat out for this tutorial because unfortunately the microphone doesn't pick up the sound very well from this unit, even though the sound is extremely loud. But for my layout, it will be in the center position because that is more than enough volume for a model railway layout. Now going back over to the Digital Town website, once again, obviously I have the circuit diagram. Click on that to enlarge it. Also, you can click to download today's sketches. And finally, there is a link to the data sheet. Now the data sheet is the same as the DY-HV5W. Let's just open that in a new tab. So obviously the image is wrong, but all the rest of the information in here is correct. Now for this example, I have already created a few functions to play tracks, play the next track, play a specific track, set the volume. So I will be using those same functions as I've used in the previous tutorial. And if you need to see that code, just click on the DY-HV20T Mp3 player and all the code is available. Now, one other thing to be aware of, obviously this is a 3.3 volt board. That means that if I do not want to put 5 volts through the serial to the MP3 player. So that means that if you want to use this with an Uno or the Mega 2560, I've put a link to the JQ8900 on here, which happens to be the next tutorial down. And when I click on this circuit diagram, you will see that there are some voltage dividers on the TX pin, and you will need to use a similar system if you're using the Uno or the Mega, because they put out 5 volts and these boards are only 3.3 volts. So just make sure you've got all those things set up before you start. And again, you can use the same code as I used for the Uno and the Mega examples. So just to give you some background as to what I'm trying to do here, on the card I have a number of animal sounds. Hopefully you can hear some of them. Unfortunately the mic is designed not to pick up background noise, so it doesn't pick up all the sounds particularly well. The idea is that this is for a model railway, and as a particular wagon pulls in with cows, a set of random cow sounds will play. When the sheep wagons pull in, random sheep sounds will play, and I've also got random pig sounds. Now, I've managed to get about 12 files onto this. Obviously, if I wanted music, I would need to use the SD card version. But the goal of this project is that as a track comes to an end and the busy pin goes high, it will then trigger the next track to play. So that's the goal of today's project. Now, despite the mic not picking up the sounds particularly well, I must admit I have been very impressed with the sound quality of this unit, even with the fairly small speaker that I'm using. So I will be ordering some more of these because I'm impressed, and they will do the background sounds for various layout modules. So here we are in Sketch 1, and I'm going to show you a problem that occurs with the busy pin, and then we will see the solution in Sketch 2. But the problem that occurs also occurs with other boards such as the DF player, and so it's worth understanding this issue so that you can make any of these MP3 boards play better. So as always, I've put the dip switch settings in the sketch. I've done the ESP32 connections, so we're on pin 16, which is RX2 to TX, 17, which is serial to TX to RX. I'm using pin 15 for the busy pin. Again, choose whichever pin suits your project, and obviously ground to ground. I've defined a couple of pins, the RX and the TX. Again, I've given a value for my busy pin. I've got a value of play state as an integer. Current millis is the latest time of the board in milliseconds. Serial millis and then serial timer, you'll see what they are for later. These variables here are to do with the way that sound commands are sent to the board. Now, I'm not going to go into great detail as to how these works, because if you look on the sketch for the 5F, where are we? We go to the sketches for these. There is a whole set of instructions of how I created the various functions to make everything work. So there is more detail available there. However, what I have done basically is I have given a play command that will just play whatever track is lined up. There is a play next command. Coming down, there is a playback volume. So that sets the volume. The volume can be set between a value of 0 and 30. And then I have another function here called play track, and this will play a specific track. Now, there is a method to putting the files on the board or the card, depending which version you've got. You basically start with 4 zeros and 1 for track 1, and then you just keep going. I don't allow any gaps in my numbering sequence, so track 1 is 00001.mp3 and so on. Now, the way this works, obviously it builds up the command. There is a checksum that is created, and it then, once it's got all of the commands in an array, it sends then those bytes to a function called send command, and send command transmits this data over serial 2 over the TX pin to the player. Now, this is, if you like, a very simple system. So to get it started in the setup, I've obviously got the serial started. I've then got serial 2 started for the ESP32. I've got a timer. I've set the busy pin as an input, and I've called the function playback volume. That is this function here. I've given it a value of 29 so that it starts off with the sound being set pretty loud. Then we come down to the main loop. So as we look at the main loop, it's very, very simple what I've done. You'll notice I've commented out some code here because we're going to use that in the next version. But all this is going to do is it is going to wait for the busy pin to go high. So greater than 0, we're going to do a digital read. Now that means that when that pin goes high, no track is playing, the unit isn't busy, so that it would make sense at that point just to play the next track. So that would mean that every time the board is doing nothing, I will immediately play the next track. Now when I click on play next, The good thing is coming up to the function, it will send the command across. It will then call the send command, which basically sends the information across. And not only does it send the command across, but it serial prints the command out so that I can check that the command is being sent correctly. So let's load this up and you'll start to see a little bit of a problem. Now, from my point of view, the system is now working. I'm on sheep in the background very quietly because that's what I require. But I want you to keep an eye on the serial monitor, because in a minute this track is going to end, and as soon as it does, if we look at the sketch, when the track ends, the busy pin will go high, and I will immediately then send a command to play the next track. Now, the next track has now started to play. What I want you to notice now is just how many times the command was sent. You would think that the busy pin would go high. I would send the track would then start playing, so the busy pin would go low, and therefore I would only send the command once. But as you can see, it has sent this probably 100 times, something like that. So let's have a look at what is going on. Now, when you start to look at the serial monitor, as we look at the problem, the thing that we need to think about is timings. Now, I want you to look at the times here. Obviously, the serial monitor only goes down to sort of milliseconds, but you can see that basically we have lots and lots of commands being sent what would look like simultaneously, and it's because they are being sent across so quickly. But the issue that we have is when we think about these MP3 players, and this applies to all the different MP3 players that I've come across so far, they all use a baud rate of 9,600. Now I'm going to bring across a little spreadsheet here. 9,600 baud, that is the number of bits per second. There's 8 bits in a byte, so that means we can send 1,200 bytes per second, so 1,200 characters. The time per byte is 0.83 milliseconds or 0.0083 seconds. That means to send 5 bytes, which is a pretty average command length, we're going to use 0.004 of a second. Now, let's think about the process that happens here. We have our circuit diagram. I'll just try and quickly find that one. Where are we? Circuit diagram. So let's imagine our pin has gone high. Our ESP32 will do a digital read. Now on an Arduino Uno takes, where was it? 0.000036 seconds to do a digital read. So we're talking 3.6 microseconds, not milliseconds. So virtually the moment that the busy pin goes high, the ESP32, which is quicker than the Arduino, is going to have picked that up, and it will go, the track's ended, send the data across. Now it sends that data across, but if we go to our spreadsheet, we can see that it takes 0.042 seconds roughly just to transmit the command, that is, to put the command into the buffer and to get it moving. So the ESP32 will put that information straight into the buffer super fast, and then once it has done that, according to my code, let's just bring that up again. So according to my code, it has sent the transmission, It now whizzes down to the bottom of the loop, comes round again, and it does a digital read again. Now, from the end of that transmission to doing the digital read, if we come back to the spreadsheet, that is going to have taken, what are we looking at? I would be surprised if it took 15 microseconds. So in other words, the speed that it took to go round and read the pin again is faster than it is for the actual transmission to get from the ESP32 over to the board. Now, once it's sent its 5 bytes over, I've put some figures on here to sort of give myself some ideas of where we're going. I'm going to say optimistically it does it in 0.0125 milliseconds. Pessimistically, it could be up to 0.1 of a second. Now, we don't only need to send the data across to the MP3 player. So we've got to transmit. That MP3 player now needs to receive it. So it can only receive the transmission as fast as it's being sent. It then needs to read the command, check that the data is right, do the checksum and all the rest of it. Once it's happy, it's then got to go, okay, what is the next track? It's then got to read from the memory or the SD card. Then it's going to start playing and it's going to set the busy pin. Now, the fact is that in the time that that takes, the Arduino or the ESP32 will have been around this loop over and over again, constantly saying, send the next, play the next track, play the next track, play the next track. And that is what all these commands are. It's actually saying, play the next track because the busy pin hasn't lit up yet, when in fact it could take 0.1 of a second for the MP3 player to process the fact that a command has even been received. Now, the issue that comes out of this is it has said here, play the next track. So the MP3 player, even before it will play the next track, but even before that track has virtually started playing, it will read from the buffer the next command which says play the next track. So it may take some time. It may sort of have to empty the entire buffer, restarting new tracks before it can actually get a track running. And the track that will play, although we've asked for the next track, won't be the next track. It will probably be a buffer length of tracks away. So in the next sketch, we're going to look at how we actually deal with making the next track play rather than some random track. So for sketch 2, we're going to start to introduce some states and some timing elements. Now, for anyone who's followed any of my other tutorials, current millis is used all the time. Let's just turn the cows off. That's it, bit of silence. Okay, let's start working on this. So what we're going to do basically now is debounce the busy pin using the serial timer. Now I'm going to use 250 milliseconds as my time. So what I'm going to allow, that means from the moment the busy pin goes high, I am not going to transmit to the MP3 player for 0.25 of a second. So going down to the main loop, current millis equals millis. So we're taking the current time of the board in milliseconds and then doing a digital read of the busy pin. If the busy pin says that the board is not doing anything, nothing is playing, it's going to increment play state. It's also going to reset it to 0 if something is playing. Now, once it has done that, we then have a timer here that is going to say if the play state is equal to 1, and only if it's equal to 1. If the value has changed for, it's gone higher, I don't want to do anything. So basically once this system starts, it will only play a track if the timer is triggered and the play state is equal to 1. So what could happen is we could get a value of 1, we send a transmission to play the next track, we then reset the timer, but when it comes round again, play state will now be 2, but this time it will not send a track command, a play next command, because the value of play state is wrong. So it will only send a single command. So let's clear the serial monitor and get started. So I've started the sketch, and now when you look at the timings of these things, you can see that I've got one track here that was only 3 seconds, another one that's a couple of seconds. Right now the track that's playing is a much longer one. You've got one here that was, well, 15 seconds, something like that. But you can see that it is now only sending a single command across when the busy pin goes high. So that part of the project has been successful. Now at the moment, the way the sketch is written, it will always just play the next track on the card. We could get it to play the same track over and over again. For that one, you would just play track and give it the soundtrack that you want to play. In this case, it would be 2. But what I wanted to do was have random sounds playing. So the way that works here is my cows are on tracks 1 to 5, because the random gives 1 to a value of 1 less than the final figure. So that would play tracks 1 to 5. And every time it comes round, it will just pick a random track number, and I will get a different cow sound. Now the other thing that I can do is, by uncommenting this last line, I can also change the value of the serial timer. That means that it will change the time when it triggers the next track. So instead of it being 0.25 of a second, it's now going to be a random value between half a second and 4 seconds. So that will give a lot more variety on how the tracks play. And obviously you can see I've got my cows, my sheep tracks, and my pig tracks. And depending which one of these I uncomment, that will play the appropriate tracks. Now obviously going forwards for my project, there will be a trigger that means that either these tracks, or these tracks are playing, depending on, to be honest, which wagon load of animals arrives at the station. So I hope that has helped with understanding some of the issues on using things like the busy pin, and the fact that your board can be running a lot faster than your MP3 player. Now you may say, well, why don't they improve the speed of the MP3 player? Why would they? It would cost a lot more money and would have very little effect for most users of their projects. So they are what they are, and nothing's going to change. But if you want to get around it, this is how you do it. So I hope that one's been useful to you. Don't forget, all the resources and the code are on the Digital Town site. And from me and all the farm animals in the background, it's thanks for watching, and please click the like and subscribe if you want to hear and see more of this content. So that's it for now. See you in the next video. Bye for now.